Good morning. Welcome to AP Computer Science A. Today we're going to go over section 7.6, Insertion Sort. On the last section we covered selection sort, and in the same way that you don't need to code the algorithm in your AP exam, you do need to be able to be familiar with the code and with the process. So today we're going to concentrate on both. If you look through your notes, they have the steps for the algorithm. They have a sample array in the process, and they also give you both the selection sort that we covered on the last section and your insertion sort. You should also have your Google Doc open, and let's get started. I have the code right here on the right hand side. So our selection sort has a while loop inside a for loop. And we're going to start our for loop with j or I equal to, in this case, j equal to 1. And what we want to do, we want to be able to start with each one, and we want to be able to sort the first one. And then we're going to go and keep the first two sorted, and the first three sorted, and the first four, and so on. So the reason that we start with 1 is because if we only have one element, therefore we know that the one element is sorted, correct? So therefore we're going to start with j equals 1. Now what we're going to do, we are going to have a temp variable where we're going to store the element j1, and we're going to assign it to temp. Then we're going to keep track of a possible index, of the index where we might be able to insert the value or the element, and in this case it's going to be impossible index equal to j, and we'll talk more about that in a second. So now that'll be equal to 1. And now we're going to go through a while loop. We're going to go through a while loop while possible index is greater than 0, which it is because it's equal to 1, and the temp is smaller than the previous element. So is 19 smaller than 57? Yes. If that's true, then we're going to go through the while loop. We are going to save the previous one. Elements are possible index minus 1 will be 1 minus 1 will be 0, and we're going to save it to the one ahead. And also we're going to reduce the possible index, so now the insertion might happen at 0. And now we go through a while loop again. Is possible index greater than 0? No, because it's equal to 0. So therefore the while loop ends. And now the last thing to do is to be able to place our temp back into the proper location for the insertion, which is at index 0. And now we have our first two elements sorted. Now we're going to come back to our for loop, and now it gets increased by 1, so now j equal to 2. We're going to save the element at 2 into our temp. We're going to assign it to the variable temp. And now possible index, the insertion, might happen at 2. Now we go through while loop. Is the possible index where we can insert is greater than 0? Yes, it's 2. Is temp smaller than the previous element? It's 80 smaller than 57? No. So therefore, we don't go through the while loop. And last, we're going to place the temp into the possible index, which is at 2. So therefore, nothing changed because it was placed in the right location. So now our first three elements are sorted. Let's go through one more algorithm. So now our j gets increased by 1, so now it'll be 3. We're going to assign the element 3 to the temp, and our possible index, the possible insertion, might belong at 3, which we know is not the case, correct? That should be index 1. But let's go through the loop or while loop. Possible index is greater than 0. Yes, it's 3. Is the temp smaller than the previous element? Is 26 smaller than 80? Yes. So therefore, the 80 gets moved up 1. And now our possible index gets reduced by 1. So now it's going to be 2. We go through the loop. Is possible index greater than 0? Yes, it's 2. Is temp smaller than the previous one, than 57? Yes. So therefore, the 57 gets moved up 1. And our possible index gets reduced by 1. So therefore, our possible index for the insertion might be at 1. We go through a while loop again. Is possible index greater than 0? Yes. Is the temp smaller than the previous one? No. So therefore, we don't go through this while loop. And the last thing is be able to place our temp into the possible index, which we know is the correct one. So now all 5 elements, or all 4 elements are fully sorted. And now we can continue with the next one. We know that 95 will be in the right place. Another way to think about insertion is that basically we're going to insert this into the possible index where it belongs. Not here, not here, but here. The 4, not here, not here, not here, not here, here, over there. The 45 will be here. The 14 will be here. And lastly, the 73 will be located there. And now all of the elements in our array are fully sorted. So that is the algorithm for insertion sort. Once we get to merge sort on unit 10, that's going to be a lot more efficient, but it will be more challenging to code. Have a great day, and I'll see you next time.